Hi students, this is T. Balakrishna, Chemistry Lecturer, GPT Kottagudem. Today we are discussing about the fundamentals of chemistry. In these fundamentals of chemistry, we are discussing about the atomic structure. Here, Niels Bohr tried to explain the atomic structure based on Planck's quantum theory and Rutherford concept. This theory was proposed by Niels Bohr in 1913. Important points in Bohr's atomic theory. The electrons in an atom revolves around the nucleus in certain fixed circular path is called orbits. The electrons in an atom revolves around the nucleus in fixed circular path is called orbits. Every atom have electrons, protons and neutrons. In these electrons, protons and neutrons are present in center of the atom that is called nucleus. Electrons are revolving around the nucleus in fixed circular path. That path is called orbit. I saw the diagram. So is a red color mark is representing the nucleus. This nucleus is contain protons and neutrons. This is a blue color is representing the electron. These electrons are revolving around the nucleus. Just like here electrons. This is a nucleus. Electrons are revolving around the nucleus in fixed circular path. That path is called orbit. Just like okay, right. So next, every orbit is associated with a definite amount of energy. So that orbit is called energy levels. Every orbit is associated with a definite amount of energy. So that orbit is called energy level. So as long as electron revolving this orbit, it does not radiate the energy. So the energy of orbit is stable. So that orbit is called stationary orbit or energy level. So there are the points. Each orbit is associated with a definite amount of energy, so that orbit is called energy, is also called as energy levels. So next, as long as the electrons revolves in an orbit, it does not radiate energy, hence the orbit are called stationary orbit or energy levels. Stationary orbits are energy levels. There are many possible circular orbits around the nucleus in each atom. Each orbit is denoted by n. N is called principal quantum number or Bohr's integer. So there are many circular orbits around the nucleus. There are possible to many number of circular orbits around the nucleus. So if there are many number, how to identify by using of this number? This is principal quantum number denoted by the letter n. N is equal 1, that is in a first orbital. N is equal to, that is in a second orbit. So orbit, there is a difference between orbit and orbital. There is an orbit, n is equal 1, there is a first orbit, n is equal to, that is in a second orbit, n is equal to, that is in a third orbit. It's also represented in this manner. It is in a nucleus, is in a positively charged nucleus. So uh, n is equal 1, that is a first orbital or k shell, n is equal to second orbital or l shell, n is equal to 3, that is in a third orbit or m shell, n is equal 4, that is in a fourth orbit or n shell. So it is an orbit, not an orbital. So it is also represented n is equal 1 first orbital or k shell, n is equal to the second orbital or l shell, orbit not orbital, n is equal to, that is in a third orbital or m shell, n is equal to 4, that is in a fourth orbit or n shell. So as the n values increases, the size of the orbit as well as the energy also increases, If the n values increases, the size of the orbit also increases. This is in the first orbit, that is size is this. N is equal to the second orbit, the size is this. N values increase. N is equal to, that is in the third orbit, the size is this. If the n values increases, size of the orbit is increases. So we easily understand by Observe this diagram. Okay, as the n values increases, size of the orbit as well as energy of orbit also increases. That means the second orbit energy is higher than first orbit. The third orbit energy is higher than second orbit. So as n values increases, size of the orbit as well as energy of orbit also increases. It is a very important point. N values increases, size of the orbit as well as energy of orbit also increases. Next one, the electrons revolve around the nucleus in an orbit. The angular momentum of electron is an integer multiply of h by 2 pi. H by 2 pi. If the electron is revolving around the nucleus in fixed circular path, every electron has some angular momentum. That angular momentum is calculated by formula mvr is equal n into h by 2 pi. So in this formula, m is mass of the electron, v is the velocity of the electron, r is the radius of orbit, h is the Planck constant. The Planck constant value is 6.625 into 10 to the power of minus 27 x per seconds. Next, n is the principal quantum number. It is an integer value. So here r value, v value is vary with the depending upon the electron present in which orbit. So mass of the electron is constant. Next one, the electrons are jumps from lower orbit to higher orbit. It absorbs the energy. If it is jumps from higher orbit to lower orbit, it emit the energy. That energy is called radiation energy. The higher energy orbit, high energy, low energy orbital have low energy. So if the electron jumps from higher to lower, it emit the energy. If they jumps from lower to higher, they absorb the energy like this. So saw the diagram. The electron jumps from fourth orbit to second orbit. So it lose some amount of energy because before that it have high energy orbital. If it is enter into low energy orbital, it release some amount of energy. That energy difference is called radiation energy. That radiation energy is calculated by the formula delta E is equal E2 minus E1 is equal H nu. The energy of radiation is emitted or absorbed is equal to the difference in energy of the two orbits. So electron jumps from fourth to second, for energy of fourth orbit minus energy of second orbit. So such amount of energy is released from the atom. That energy is called radiation energy. Radiation energy. In this formula, delta E is equal. So we saw the diagram, that is radiation energy. So electron jumps from. We have another diagram also to understand this one. Uh, so this saw this diagram. So if the electron is rotating in second orbit, if they jumps from second to first orbit, it emit the energy. If they are absorbed the energy, the electron is jumps from second orbit to first orbit. So that energy is called radiation energy. The energy is called radiation energy. As you clear, if the electron jumps from lower to higher, they absorb the energy. They jumps from higher to lower. Second నుంచి ఫస్ట్ జంప్ అయినప్పుడు ఎనర్జీ తీసుకుంటుంది. సెకండ్ నుంచి ఫస్ట్ వచ్చిన ఎనర్జీ ఇచ్చేస్తుంది. సెకండ్ నుంచి థర్డ్కి వెళ్ళినప్పుడు ఎనర్జీ తీసుకుంటుంది. దట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ the calculated formula delta E is equal E2 minus E1. Okay, right. Delta E2 minus E1. So in this formula, delta E is the energy difference. E1 is the low energy of low energy orbital. E2 is the energy of higher energy orbital. H is the Planck constant. Nu is the frequency of radiation. Okay. Okay. Energy of high energy orbital, energy of low energy orbital. H is the Planck constant. Nu is the frequency of radiation. That amount of energy is radiated from the atom by losing or gaining energy. Thank you, students. Thank you. Thank you very much. This is T. Balakrishna, GPT, Kottagudem. Thank you. Thank you very much.